excited to talk about SatLayer, which is a project that I co-founded with Mike, who's sitting over there. So what is SatLayer? SatLayer is eigenlayer layer for Bitcoin, and today we're going to talk a bit about what that actually means and some of the architectural decisions we made in making that. So we decided to build SatLayer on top of Babylon, and we'll talk a bit about Babylon's architecture and also where SatLayer lives on top of that, and why we chose this particular architecture versus other ones. In general, the idea is if you are building a protocol where you are restaking Bitcoin to secure the services, the idea is that you want to kind of minimize your trust assumptions on like other kinds of like situation. You essentially, in an ideal situation, you want kind of like the security of that particular ABS that's being secured to be proportional somewhat to the stake of the Bitcoin that's securing it, and not necessarily like the stake of that Bitcoin plus, you know, whether some guy in multi-sig is going to rug you, or you know, whether you have like an MMN group of like participants to, you know, some kind of quorum and like just take all your Bitcoin. You know, that's not what you want. So in that sense, Babylon is kind of an ideal substrate for that, because Babylon is permissionless and it allows you to have some level of a proof of stake guarantee on and essentially allows you to have like very strict guarantees on the safety and liveness of like let me back up a little bit. And talk about high level of the architecture.
So I have a quick question.
Yeah.
Maybe a simple
sure.
question. So for Ethereum, because Ethereum is POS, right?
Yeah.
So you use the Lido. So people stake ETH into Lido
Yeah.
and become a stake ETH.
Mm-hmm.
Then the stake ETH, however, eigenlayers in stake ETH, we can reuse the stake ETH.
Yeah.
Right? They call it restaking.
Mm-hmm.
Then you stake your stake ETH to eigenlayer, get extra benefits, airdrops and stuff, and they're promising they're gonna build an ABS around this restaked ETH.
Yeah.
Right? Because you put stake
Yeah.
into it. But in Bitcoin, it's proof of work, right? There's no staked Bitcoin.
Yeah, it's true. So it's a bit of a, people talk about restaking on Bitcoin and they think they do that just to draw the parallel to eigenlayer. But you're right, like depending on what the underlying Bitcoin asset is, there is no necessarily restaking. And people are kind of getting a bit fast and loose with this term even on Ethereum. Like you have protocols like Symbiotic, Carrick, who are taking in LP tokens, you know, LRTs, which is bonkers, USDC, things like that, as collateral. Yeah, I mean, these are not, some of these are restaked assets, some of these are just assets that have been staked before. So I think in general, maybe we can redefine the term, but it may be better to say, okay, this is like class of protocols. We're taking some asset that has value, like something has like certain definable value, and you're using that as collateral to secure a set of off-chain services. So essentially you're saying, I will give you the ability to put this into a smart contract and say, this is going to be used as some kind of stakeable collateral that can be slashed upon this behavior. And this slashing behavior and also the rewards I get as a result of providing the service to you are defined programmatically by this smart contract and the architecture of this particular active validated service. And I'm not sure how you would say that succinctly, but you know.
So basically just trying to make Bitcoin has more utility. Right?
Yeah. I mean, I was talking more about what's going on in Ethereum, but you're right. In Bitcoin, I mean, Bitcoin has value. I hope we all agree on that. So, you know, it applies to Bitcoin as well. And you know, we could talk about base Bitcoin. We could talk about Bitcoin that has been potentially staked to something else. Like, you know, if you have a Bitcoin that's been staked to secure a Babylon chain, and I'll talk a bit more about what that means later on. And then you then take that same Bitcoin and you make tokenized derivative, and then you use that to secure something in SatLayer. Then that is essentially a restaked asset. But I think this is going to confuse people for sure. Yeah, because we're kind of playing fast with these definitions. But yeah.
But to that regards, probably in the future there's AVS for Solana. because
Yeah.
Solana become popular.
There is.
Right.
There's already that. Yeah.
Okay,
Called
it's just going on and going on and going on.
SatLayer.
What's
Yeah.
it called? SatLayer?
SatLayer, yeah.
Hmm.
Why there's no staking service for USDT then? Like,
There's
was
one
it-
for USDC.
There's one for USDC as well?
Yeah, symbiotic.
Wow.
Yeah.
It's just going on and going on.
Yeah, symbiotic and Carrot will both accept USDC deposits, I believe.
Okay.
I'm not sure about USDT, but I wouldn't be surprised. Basically, any asset that has value can be used for restaking it. And this concept of restaking was not born in Ethereum. This was born in Cosmos with the idea of interchain security and mesh security. And a lot of eigenlayers have been doing, and quite well to be honest, it's just taking a lot of Cosmos innovations, bringing them into Ethereum, and then force feeding them back into Cosmos, which is pretty funny, but you know, it works.
Okay.
Yeah. But so, what does it mean to eigenlayer for Bitcoin? Eigenlayer means that you have the ability to programmatically define, like I said, define payment for use of collateral, and also, no one can read that. Like, and also slashing conditions. And if you want like the ability to fully programmatically define both these quantities, you essentially need the ability to, you need some kind of Turing complete scripting language. And I just learned 2 days ago that Bitcoin script is actually Turing complete. But the reason why you can't do this on Bitcoin script is because the Bitcoin block size is limited and Bitcoin is awkward to work in unless you're a super genius who can program blockchains like Super over here. Yeah. But for most of the rest of us, we don't think that way, and no one's gonna build their own computer on top of BitVM to do this, or at least most people won't. So how do we get around this? Well, we need some kind of smart contract layer where we can kind of accept Bitcoin collateral and use it to basically, and then define this protocol where people can kind of specify the slashing conditions and also the payment conditions for each of that collateral to consume some kind of service. Well, why don't we use Ethereum? Well, because that introduces extra trust assumptions. Like, let's say we take our Bitcoin, we have Bitcoin, which is pristine collateral, which will work, and then we put it onto Ethereum, and then we run a restaking protocol here. That's bad, because now your protocol is dependent on Bitcoin and Ethereum, whereas we want to just get on Bitcoin. So we want to build this thing just on Bitcoin. Okay, well, what if I say I have an MMN multisig, and I would like you to deposit your BTC into this, and in return, I will mint you a tokenized BTC on my special chain. Let's call it Botanics for no apparent reason. And now you can run your program on Botanics. Well, that's also not great because you got an multisig, which is in the middle of this. So it's like, let's say the quorum is compromised. Like, what's going to happen to all the BTCs minted on that chain, and also the consensus? That's not good. So you want something that's like really secured by Bitcoin, and in a way where the trust assumptions are not dependent on something external. And that's where Babylon comes in, and why Babylon's kind of like in a unique spot, because they, from the very beginning, tried to like really make sure the trust assumptions are permissionless, kind of trust minimized, decentralized, all this stuff. And so kind of get a bit into what the Babylon protocol is and why it's useful as a smart contract layer substrate for what we're trying to build. Let's see. Okay, yeah. Okay, cool. So at a high level, what Babylon's due to do is Babylon's due to take any kind of proof of stake blockchain and add Bitcoin-based finality to that blockchain. And finality is a term from consensus algorithms. And what that means is that once a particular state of a distributed system is finalized, it means that unless there is some kind of safety violation, in which case, you know, some underlying assumption protocol has been kind of like what's it called, like violated. Like let's say you say, okay, these transactions are finalized as long as 2/3 of the value says honest. like as long as these particular safety bound, as long as particular known bounds not violated, everyone will agree that this is the particular state of the chain. So for proof of stake chains, they normally come to consensus via some mechanism, usually some kind of like Byzantine fault tolerant mechanism, which is tendermint. So you end up with like a set of validators, all of which who are going through this kind of like Robin, where they're kind of passing messages back and forth, and then they all eventually say, okay, we decide to sign a series of blocks. So the idea for Babylon is, since this validator set is dependent on some level of cryptoeconomic security, which is like potentially not, not the most sound, like it may be some low market cap altcoin, or it could be, or it could be something that's not really staked that much. What if we could instead of relying on this network of validators and their signatures to determine, at time T1, the state is now S1, what if we could instead rely on Bitcoin stake to do that? And the way you do this is as follows. And this is where the emulated covenant stuff comes in. So we have Alice on Bitcoin, and she creates a special deposit transaction, P1, which deposits to a vault. So she sends her Bitcoin to this vault contract on BTC. And this vault can only spend the Bitcoin in one of two ways. The first is with an unbonding transaction. So, and that means that after 3 days, the funds go back to Alice. And the second is with a burn transaction. And that means the Bitcoin in this goes to a specified burn wallet, which is kind of specified ahead of time. So this goes to somebody else essentially. So as I mentioned before, and something that Ryan brought up yesterday, it uses a technique called emulated covenants, which is it's not like a full covenant so the actual definition of a covenant is a script in which the outputs can only be spent by another script public key. It's like a very general term. It's like, okay, I can define any script public key as something which can validly spend the output, and this depends on an opcode which is not implemented called OP check template verified, or OPCTV. But this is a covenant which only allows you to spend the Bitcoin in two different ways. You can unbond it and return it to a private key, or you can commit it to a burn address, which is a specified third-party address. And the reason for this is because, at a high level, if Alice is caught cheating in how she attributes finality to the proof of stake chain using her staked Bitcoin, then her private key, due to the nature of the algorithm, will be revealed via this technique called extractable time signatures, and then someone can essentially go in and burn her Bitcoin, and that's essentially a form of slashing, where a stake is slashed and is sent to some random address. So that's a way of kind of punishing you, and kind of making sure that you don't do this. But if Alice is behaving honestly, that if she ever wants to get her Bitcoin back, she has a reload private key. But she can use that private key to, at any point, unbond her Bitcoin. After 3 days, she'll get it back. So how exactly is this construction used to provide finality to this proof of stake chain? If you remember, this chain already has its own inborn finality mechanism based on whatever consensus mechanism it's already using. But we have to define like a new finality rule. So rather than just saying the finality is based on, say if 2/3 of the validators here are signed off on a signature on this, which includes the previous block header, the current block header and the previous block header, then your new finality rule is something like, yeah, the block is only considered finalized if it's both finalized based on the space protocols consensus rule, and also based on, and also receives signatures from 2/3 of the Bitcoin, which is staked to secure that particular smart contract layer. So essentially, you need consensus both from the base POS protocol, and you also need 2/3 of the Bitcoin which has been registered to secure it to also have signed off on it. And you can essentially prove, which I won't do, that if more than 1/3 of the Bitcoin stake equivocates, then okay, yeah, you can prove. So let me make sure I don't miss the wording here. Yeah, whenever the safety violation, in the sense that let's say there's two different blocks which have been signed by more than 2/3 of the Bitcoin stake, then at least 1/3 of the Bitcoins which have been staked to secure that chain must have equivocated, or rather, what is it? Oh yeah, at least 1/3 is guaranteed to be slashed, and that's something that I will not be proving today.
So Babylon
Yeah.
Sorry.
Yeah,
Babylon use Cosmos. Doing their post chain, TenderMe.
They can secure any proof of stake chain. Any proof of stake chain.
They have a chain, right?
Yeah, I mean
their chain is based on TenderMe as a consensus.
So there's two things here. The first is there's a Babylon time-stepping protocol in which all the data related to signatures for a particular block height on the underlying proof of stake chain, and also the block header, and that value set is kind of time-stamped to this particular chain, and that chain is itself secured by Babylon protocol. And Babylon also has a smart contract layer, which is separate from this, which is a Cosmos smart contract layer. So it's also secured by this. But really, Babylon is a protocol which allows you to stake BTC to secure, any proof of stake blockchain. So, these are just services that Babylon offers internally as kind of examples. So the timestamping protocol is useful because it allows for you to tightly couple the Bitcoin base layer to the proof of stake layer, and this gives you some nice properties. Like for instance, you want to make sure these are in sync to make sure you can enforce this new finality rule in like a clean way. Otherwise, it can be pretty messy. Like people can unstake from the Bitcoin layer, but not pull their stake from the validator set, the proof of stake chain, and things can cut it out of sync. So you want to make sure it's super tightly coupled. So you need some kind of coordination layer to maintain that.
So the Bitcoin layer has Bitcoin, native Bitcoin, and then the post layer is...
That's any proof of stake blockchain. Give me something like Aptos or Ethereum, but yeah.
So, sorry, I don't get it. So do they have a chain?
Yeah.
So the chain is a post chain, right? Whatever it is.
Mm-hmm.
So on the Bitcoin mainnet, like you said, right, use the covenant to time locked Bitcoin.
Yeah.
And on their chain, they will mint a Bitcoin.
Yeah, and to be clear, it's not a covenant. This is just simply a Bitcoin script program, which they call an emulated covenant. But you can really only spend Bitcoin these limited ways. Yeah.
Sorry, I get it, but it's okay.
I mean, just to say it's a covenant, just like covenant's like a very general term, but this is really it's more of a vault, I would say. Yeah.
Okay.
Yeah.
So on the post chain, they will mint equivalent Bitcoin. Like you lock one Bitcoin on Bitcoin mainnet, they mint one Bitcoin on there.
They wouldn't necessarily. So there's no requirement for them to do that. The Babylon protocol itself is just this. It's a protocol for providing finality from staked Bitcoin to a proof of stake chain. What rules that proof of stake chain has are very specific to that chain. Like you could certainly create your own Babylon chain or your own proof of stake chain where that is the case, where you can say, okay, I'm going to monitor the Bitcoin blockchain, and anytime there's a Bitcoin stake to it, I'm going to mint that Bitcoin to my proof of stake layer, and that's up to you if you want to do that. But Babylon on its own doesn't enforce that natively.
Because Bitcoin doesn't have finality, right? The longest chain wins. But
Yeah.
how do they do the finality on their chains? I can only imagine they're using some Tendermint or stuff. But
No, so the finality is defined by like this mathematical rule, and you're right. Bitcoin could reorganize, but the idea is that it's just much more expensive to attack Bitcoin that way than it would be to attack any proof of stake chains. And if it ever gets to the case where there is a viable economic attack, then it could reconsider the economic value of the protocol. But like the idea is, okay, let's say that I can attack proof of stake chain, and if I manage to do a reorg on that chain, let's say I make like I don't know, like $100,000, but it would just cost you a lot more to like basically to reorganize Bitcoin than that. Like let's say you wanted let's say you wanted to go back into the past and like rewrite a particular blocks like the particular blocks like attestations, and you were a malicious person. Actually, you would still get slashed because you've revealed one signature on the base chain, and then you've then revealed different signatures. You would still get slashed. Actually, it wouldn't matter. Anytime you equivocate, you get slashed. So it wouldn't really be that good of an idea. If that makes sense, yeah.
Will SatLayer or Babylon provide like libraries for proof of stake chains to use this consensus mechanism?
So actually, we're building on top of Babylon's smart contract layer.
Okay.
Yeah. So, I mean, like the thing is like SatLayer is kind of trying to enable eigenlayer functionality, which is it's like a different model. Like eigenlayer, the way it works is you have these service manager contracts which define slashing behavior and payment behavior for a particular ABS, and this is like these are almost like functions you write within a smart contract. It's like if user provides like invalid ZK proof, or if user provides proof of custody proof, or if user does a checkpoint every 1 hour, then slash their stake or something. It's like much more general in terms of how you can define what happens. This is like a very specific form of slashing. But we only do this because we need to use this to create a proof of stake chain, which has a smart contract layer that we can then build our protocol on top of. So that's why we're kind of going through all of this.
And you said the chain will be Cosm.
Yeah, that's just Babylon. We could probably deploy our own EVM chain if we really wanted to, but Babylon's deploying Cosm Blossom chain, and I would think they're going to direct quite a bit of liquidity and attention to it, so we're just going to build on that one.
I mean, IBC will be a great addition as well.
Yeah, we'll have IBC. That'll be good. We're actually potentially working with OpenBit on the bridging protocol, so yeah.
Sure.
Yeah, I mean, if you want to, no one's forcing it.
yeah, you want to.
Okay, cool.
Let's do it.
Okay, cool.
There's a question. Due to this construct, someone said yesterday the only way you can get slash is if you double spend.
If you equivocate, so
like, what about like just bad actors? Like, what if you're just spamming the network?
yeah, I mean, I think that this is probably a big area of research for Babylon. Not just bad actor spamming, but also let's say you just don't sign stuff. Like what happens? Like let's say you're just not signing stuff with your Bitcoin key. Yeah. Who knows? It's a good question. Yeah, I assume we have to. But the thing is, like Babylon can't natively punish that kind of behavior. So maybe you could punish it on the smart contract layer. Sorry, on the POS layer itself, a certain way. But like, you couldn't punish someone.
But the only collateral you have for those nodes on the POS layer is in the Bitcoin chain.
No, because
their staked Bitcoin is on the other chain.
They're dual staking, so they're staking the base asset for whatever POS chain.
Oh, you have to
validate it.
Oh, yeah.
And they're also staking Bitcoin. And I'm not sure if there's some level of balance that needs to be maintained there that one's enforcing, but I wouldn't be surprised there is. But the idea is, okay, the only way that you can get slashed here is if I've assigned h of t1 and h of t1 prime. So I assigned two blocks at the same height with different signatures, and if you do that, then this EOTS scheme reveals your private key, and then anyone can then use that to burn. So that's the only way to get slashed on the Bitcoin layer. So there's actually no punishment for inactivity. If you're not signing stuff, no one can actually do anything. Yeah.
So how do you link that? Like, you say you have to do stake. How do you link the same guy from Bitcoin mainnet and to the post chain? They have to link, right?
Yeah, you're running essentially a validator client, which has both of a
Same.
Bitcoin client and the proof of stake chain client. Yeah, and you kind of register with both in the Babylon protocol.
Oh.
That's why they have this this timestamping layer, this coordination layer they built. Yeah,
Is that where the tokens?
maybe.
Oh.
I don't know. It could be.
Well, you said you need a token to stake in their Cosmos chain,
Yeah.
and then you get yield out of the rewards for being a validator on their Cosmos chain.
Yeah. Yeah.
And then to like unstake your Bitcoin, you have to like,
Yeah.
I don't know what.
Yeah, I mean, ideally, this thing kind of keeps everything in sync. So, like, I think you probably have to modify your. You probably have to, like, I think you probably have to modify your Cosmos chain so that it's somewhat slaved. Oh, we can't use that word anymore. What was the word? What was the word? You can't use master slave.
Bound?
Bound?
Yeah, but like
Yeah.
people said, you know how like you can't use like master slave to as like peace usage. You have to use something else. What was the new politically correct term? I forget.
I don't know.
Does anybody know?
Yeah.
Like
Me?
follower?
Yeah. Yeah.
Follower.
Yeah. Also, yeah, you can't even call like your main GitHub branch master anymore. You have to call it main.
Yeah. Yeah.
Yeah. Yeah.
We've come a long ways, haven't we?
We have, yeah, made a lot of progress. But anyways, in that sense, I think you have to you have to have this chain watching what's going on in the Bitcoin layer and make sure that it's kind of watching what all the validators are doing to avoid some kind of disaster scenario. Yeah. Let's see. So is how Babylon works like clear to everybody? Or yeah?
Maybe I came in late, and I'm sorry if this is obvious to everybody else, but it's not possible to slash for conditions besides double signing.
Yeah, that's the only condition. Essentially, they use what's called an extractable one-time signature scheme
Right.
based on Schnorr signatures. Let me see if I can find the actual VIP. I wrote down.
They use the covenant emulation to force them to reuse the nonce, and then they can extract the private key.
Yeah, well, what's happening is that I have to kind of dig into the details, but like basically, in the process of signing two blocks the same height, you have to reuse the same randomness,
Yeah.
and this is what allows you to extract the private key. Yeah. Yeah, there's something called BIP 340.
Mm-hmm.
Yeah. Okay, cool. So now you have something where you have essentially
So curious, why Babylon instead of something else, maybe like Core?
oh, I
Because I
mean,
know the infrastructure pretty much the same for the way Babylon is doing their timeline.
Oh, it is?
Similar to how actually we implemented it.
oh, cool. Yeah, I'm definitely open to chatting about it. Also, I think it's cool they're on Puerto Rico. So
Yeah,
Yeah.
What project are you with?
Core then.
yeah.
for DAO,
Yeah.
did you guys, sorry, I missed the question. You said, why don't you use our stuff?
Yeah, I was just saying similar because we implemented this actually with the time locking and then having the native yield viewable, and we're doing the same thing where you can actually build an app chain using our consensus.
Oh, cool.
So you're like you're a Babylon like solution.
I'd say Babylon is a core-like solution,
Yeah.
but
So are you doing like combination covenant stuff?
I mean that is a bit more technical jargon than I'm used to actually saying. But we pretty much launched this about 18 months ago on our mainnet. And the way it works, I think, which might make it more helpful, is when you stake your Bitcoin, at that level you're actually doing a time lock transaction. And the reason why you receive the yield is because in order to be elected as a validator in the set, you have to have a certain amount of Bitcoin delegated to you, a certain amount of cash delegated to you to be able to Bitcoin mining, and then a certain amount of core staked to you as well. So that's why you actually start getting this yield, is because you join our consensus. So that's very similar to what Babylon's doing too.
Okay, cool. Got it.
And then with the Bitcoin, I'm pretty sure you actually don't, when you do this non-custodial time lock stake, you don't actually mint Bitcoin on the other side.
Yeah.
It just stays within your wallet because there's no way to slash it. So there, you
There's
wouldn't
no
be
way
able
to slash it in CoreDAO, or there is?
If to do the non-custodial stake, there isn't because the Bitcoin doesn't leave your wallet.
Oh, it
It
doesn't your
stays
wallet,
in a
got it.
time lock, which is exactly what Babylon's trying to replicate as well.
No, Babylon's, you can actually take someone's Bitcoin if you.
That's
if
like,
you-
but they're implementing the same time lock. So when you do the time lock, you can't actually take the Bitcoin because it
Oh.
stays within your private
No,
key.
there's two separate things. The first is, there is a time lock mechanism with Babylon, you're
Mhm.
correct, in the sense that when you unbond, it takes you 3 days. But if you trigger the burn output,
Mhm.
that sends it to a particular address, and that can be triggered anytime.
Mhm.
So you can in Babylon actually slash somebody.
Yeah.
And they won't launch with it, but that's the
Yeah.
plan.
Yeah.
Yeah. And I think you need slashing. I think you need slashing for safety.
Of course.
For PR purposes.
Yeah.
What is the slash
Yeah.
Bitcoin do?
What?
What is the slash Bitcoin?
It goes to.
Say his wallet is.
Doesn't it to
Sorry.
me?
Only
Yeah.
I don't mind.
Protocol revenue.
Is it burned? Slash?
No, it just goes to a predefined address. This is like essentially when you
Predefined
yeah
address.
when you set up this when you register in Babylon, you send a transaction which has a Bitcoin script which sets up this emulated covenant type structure. Where it's like, okay, I'm going to send these funds to an address, and the only way that these funds can be spent is in one of these two ways. Either I could spend them by unbonding or drawing up 3 days, or I could spend them by burning to a predefined address.
So it's burned. The address,
Well-
no one has the private key.
I mean, you can set that where you want. So, but if you set it to, like, let's say an address that's like, not protocol approved, then that protocol may choose not to accept your Bitcoin stake as part of the validator set. Okay, so imagine a construction like this. You now have a POS chain, which is Cosm Watson VM, full terms of programmability in Rust. And you have a set of Bitcoin stakers. And they all put their BTC into a series of vaults. Which are securing this Cosm Watson layer. But anytime somebody puts their BTC in one of these vaults, we then mint the BTC, like you're talking about, to that layer. So now it's like, okay, we've essentially, and we're actually working with third-party protocols that will essentially do this for us, but now every time Bitcoin is in here, we put the Bitcoin here. And so what does this give us? It gives us a layer where we have a bunch of Bitcoin on a layer, which is itself secured by the Bitcoin, which is staked to secure it. So now you have essentially a very clean assumption. Like if 2/3 of the Bitcoin which is staked to secure this layer is honest, then this layer should provide secure finality for any kind of smart contract operations which are on top of it. So what does that get you? Well, now I can define a series of smart contracts on this layer to allow for completely flexible slashing conditions, and this augments the functionality of Babylon. Yeah, I'm literally just going to copy in the eigen layer system architecture. Where is this? That is open. Yeah, I'll take it from memory. Yeah. Okay, cool. So on this layer, you have a set of smart contracts with the following. You have, let's say, an ABS directory. You have a state manager, and you have a delegation manager. So Alice, Bob, and Charlie, they have full control of this Bitcoin that they've now minted this chain, and they say, okay, I would like to get additional yield on my Bitcoin. What I'm going to do? I'm going to stake it in the stake manager, and then I'm going to delegate it to a set of operators. And what are these operators doing? These operators are securing a set of off-chain services using the stake which is delegated to them on the smart contract layer. And what kinds of operations are being enabled by this? Well, you could think of bridges, fast finality, the rollups,
Oracle.
ZK verification layers. My handwriting's so bad, sorry. Oracles, GA layers. GA layers. I don't know. You could probably kind of sky's the limit. There's just a lot of potential applications. Like any kind of off-chain service, you're not bound by needing to prove the blockchain. You're not bound by needing to pay people a certain way. You can really just kind of specify any kind of conditions for slashing somebody or paying somebody you want to. And that's kind of the power of this particular approach. And that's what you get relative to this. Here, you can only punish somebody if they equivocate. Here, you can punish or reward people arbitrarily for whatever you want. And that's essentially kind of like what we're bringing to the ecosystem. And the reason we're building Babylon is because of this deep trust assumptions, in the sense that we don't have to rely on anything other than Bitcoin security for this to work. So the thesis is that if you're a Bitcoin protocol and you want to consume some kind of off-chain service, if you want to kind of minimize the external dependencies, the trust dependencies of what you're building, then you can do something like this, because you're essentially borrowing Bitcoin security to make that service work. And let's say ETH proof of stake has a bug or something, and you're an eigenlayer, you're not going to be affected if you're on Bitcoin. And as a Bitcoin protocol, why would you want to introduce dependencies on something like external, like Ethereum? It just wouldn't make much more sense if you can avoid it. Or why would you want to, introduce such centralized trust dependencies? So yeah, it's at a high level, kind of like how we work.
So is the ABS a bunch of smart contracts?
Yeah,
It's not like nodes or anything, just smart contracts.
there are nodes. So you have kind of this off-chain component, which is nodes, which are normal operators. So you have node 1, and node 1 could be validating a set of ABSs, and it's kind of talking back and forth to this, and also to a set of ABS-specific service contracts, which are being deployed on-chain to help with the coordination. So that's kind of like, SatLayer is a protocol that enables this framework. We take in the BTC stake from people that have that have deposited or bridged BTC over to this chain, and we allow them to delegate it to operators, and we allow people to deploy ABSs, and also create the server manager contract to define the slashing and payment behavior. And basically, SatLayer is the coordinate mechanism that allows all this to work. And also, it allows re-app authentication, which is very important. So the idea is that if you have, let's say, a pool of like 1,000 BTC, it's actually more secure to have that 1,000 BTC simultaneously validate 5 different ABSs than it is to have 200 BTC securing every individual ABS. Simply because the cost of corruption in the entire system is much higher. It's something that was proved in EigenLayer's white paper. It's something that they call superlinear security. I mean, you can, be able to push back some of the assumptions, but yeah.
How does it scale?
Superlinear.
Like
Yeah, I don't know.
n log n or like n squared or?
You're asking. Yes, actually wrong. I'm just a parrot. No, okay. I think she's quite shaky. I regret saying that. But anyways, this is the whole point of EigenLayer. They're like, yeah, this is like, it's just much harder. That's their whole claim, is like, you know, this is a much more capital efficient system, you know, less liquidity fragmentation, stuff like that, because from here authenticate. But
I'd really like to understand restaking better.
yeah.
It's one of those things that's like feels very important, but I don't know.
Yeah. I think the EigenLayer has been playing a bit fast and loose with the theoretical underpinnings of it, for sure.
That's my sense as
Yeah,
well.
yeah. But they have a lot of narrative mindshare. And I don't know, I mean, intuitively it seems somewhat true. And let's say, it's like, you know, you would essentially need to have an attack to exist on all of the ABSs being validated by a particular pool of collateral simultaneously to kind of like make that attack viable. Versus if you have isolated pools of collateral validating individual ABSs, then any individual exploit could potentially make that pool of collateral worth attacking, you know? So
Right.
intuitively, maybe that's the underpinning of it, but yeah.
I don't know how much you know about EigenLayer. Do you know what Beigen is?
Biden?
Beigen.
Oh,
B.
B-Eigen? Oh, is it their token?
I don't know what it is. It's like soul-bound Eigen or something. It's like
Oh.
bonded Eigen.
The intersubjective work token.
Hmm.
Yeah. I mean, I know a little bit about it.
Was it called like B-E or just B-Eigen?
B.
Yeah.
Eigen.
I know about Eigen. I haven't actually looked into B-Eigen. I should probably look into B-Eigen.
I saw a presentation where they had Eigen, Beigen, and then Beigen with hat. It's like a different Beigen with a hat on it.
Oh.
I don't know, curious to understand more about the
Yeah.
diagram.
Okay, they have the token overview. I haven't looked at it in a while either. There's like, it's complicated.
Yeah. I mean, the intersubjective thing is like, I think they want to introduce a token that allows you to essentially achieve some level of quorum on slashing conditions that are more fuzzy than this. So, and also can act as like a pool of collateral that's more subjective than Ethereum, I guess.
Mhm.
Yeah. So, in essence, what they're trying to do is to get this Eigen token to be used as a dual staking token within the tax system, and also as some level of arbitration for more fuzzy slashing conditions. That was my take on it. How theoretically sound that is. I mean,
I have no idea.
yeah. Not like SatLayer. SatLayer is rock solid.
Do you have B SatLayer?
No, we're gonna go with that.
What's the token ticker, Sally?
It's gonna be Slayer. Slay.
No, but do you have a bonded Slayer and then a bonded Slayer with hat, like all of these other?
Oh no, that's true. We need more jargon.
Yeah.
Yeah,
You could do bat layer.
Bat-
Bat layer.
Interesting.
yeah, good. Yeah, I don't know. I was really hoping that the original idea was called Baby Layer, but I think that quickly yeah. Yeah. Actually, I'm curious. Do any of you know how these like EOTS, private key
Yes.
extraction stuff works? Oh,
I think it's pretty simple. It's just like, have you ever seen the thing about nonce reuse with Schnorr signatures?
Yeah.
you can solve for the private key.
Yeah.
I'm pretty
But-
sure it's just that.
Got it. And in this sense, the randomness they use must be deterministically generated from the block height. I guess it has to be. Otherwise,
So that part I don't understand how it interacts with Bitcoin. It
Yeah.
feels like that's probably hard coded somehow. Like it's like
got it.
because the hard part is forcing someone to use the same nonce twice.
Yeah.
So it's
Yeah.
probably hard coded into like the pre-signed covenant
Yeah.
thing.
Probably.
If I had to guess.
Into the actual Bitcoin script. Interesting.
Yeah.
Oh, huh.
There is a way to force somebody to use a particular nonce in Bitcoin script by using size. You can force them to make a signature of a certain size if it's a SegWit v0
But that-
signature.
That's like a specific nonce.
Yeah.
We want like that. We want to force them to use a particular random nonce.
Yeah.
Since I mean,
I don't know how to do that part.
I don't think it's possible unless you hard
But it
code
has to be somewhat tied also to the block height, right? Because you want it to be extracted only when they sign the same block height twice.
Yeah, that's a good point. I don't know.
It didn't.
How big is the pre-signed stuff? Is it just one thing, or is it like one per block for how many blocks you've
I'd have to look into the Babylon source code to check that out. It didn't describe it in the white paper or the documentation. So, yeah.
If it's like one pre-signed thing per block, then that would be like a simple way of doing it. But there might be a cleverer way of doing
One
it.
pre-signed thing per block. So pre-signed is in, but they only sign, I think, once per. Like, what do you mean pre-signed? Like sign before that they know the header, or?
Like, suppose you've agreed to stake for 100 blocks,
Mhm.
then when you do that,
It's just a time block.
but like to force them to use 100 different nonces, if they have, because you don't want them to
Oh.
like get slashed if they reuse a nonce. Like that, like they're supposed to do like each one exactly once, and there's 100 of them. And if you know them in advance, you can fix them all.
Yeah. I assume they use the same randomness for every single block. And then it's only if they sign the same height that randomness is revealed.
Oh wait, if the
Maybe they don't.
I have to think about it.
Yeah. If you can specify the randomness ahead of time. Well, I guess you have to make it obfuscated so people can't sign for you. But
This part comes from the what's the paper from Robin called? Bitcoin staking or something.
Bit stake. I forget.
That's where the extractable one-time signature thing.
oh, really?
Yeah,
So Robin invented
Stake
this?
chain.
he didn't invent extractable one-time signatures, but yes, stake chains. He wrote that, and then that's. I mean, I don't know like the actual genealogy of the idea, but it's very much like a antecedent to Babylon.
I'm done.